Hello, welcome back to Pre-Calculus. This is a video over Unit 10. We're going to be talking about additional topics in trigonometry. So the first section that we have is law of sines. And so our lesson objectives, we want to apply the law of sines to solve mathematical and real-world problems, determine whether a triangle has 0, 1, or 2 solutions using the ambiguous case of law of sines. So what we're doing is we're doing this thing called solving a triangle. And when we solve a triangle, what this means is that we calculate all side lengths and angle measures. Okay? So side lengths and angle measures. Okay, so what we would do is we would be able to, find angle A, angle B, and angle C in this case, and we would want to find the side lengths A, B, and C. Okay, now you're already given some of these, right? You're given that angle A is 29 degrees. Okay, you're given that angle B is 41 degrees. All right. Now, the cool thing is about this is that we know how to figure out what angle C is. All right. So angle C would be 180 minus 29 minus 41, which would give us a value of 110. Okay, so these are things that we know how to find. Now, how we label this, we've got angles A, B, and C, right? Let me label that this is 110 degrees. And then we have side length C, side length B. Now, side length C is across from side length, or from angle C. Side length B is across from angle B over here. So side length A would be across from angle A. And I know that side length A is going to be 6.5 centimeters. Now the question is that, how would we find side lengths B and C? Okay, we figured out what angle C was. That was easy, but what do we need to do here? Here's the kind of the hard part, okay, is we're going to use what we call law of sines to figure out what lengths B and C are. Now, the thing of it is that, and what you notice about this triangle is that it's not a right triangle. It's just a standard, this would be a scalene triangle, okay? So we don't know what to do. So what I want to do is analyzing angle-side relationships, okay? So let's just take this triangle here. And triangle ABC is not a right triangle, okay? But what we can do is if given this relationship, we can draw a line here and call it the height of the triangle, okay? And we can know that this is going to be a right angle. Coincidentally, this side over here is going to be a right angle, okay? So what I want to do is this. I want to analyze angle A. Okay, and what I know is that if I were to write my sine function for angle A, we would take our opposite side divided by our hypotenuse of this triangle here, okay? So I can write out that sine of angle A is equal to h over b. Now the other thing that I can do is I can come over here and look at angle B, all right, and look at this triangle on this side. It's a right triangle, and so then I can write out that sine of B would be the length h divided by the hypotenuse A, all right? So I've got sine of B is equal to h over A, all right? So now what we have here is we have this thing, and we have two equations using h and the variables a and b. Now what I can do is I can call this a system of equations, okay? And what I want to do is do some algebra manipulation to, draw some conclusions here, okay? So what I'm going to do is I'm going to, first step, let's just write out, I'm going to solve each equation for h, okay? And so let's do this. Let's take sine of A sine of angle A is equal to h over b. And let's solve this equation for h. So if I were to do this, I would multiply both sides by b in order to get h by itself. So I'm going to divide those out. And I get that h is equal to b times sine of A. Okay, that's the first one. All right. The next one I'm going to do is I'm going to do sine of B, sine of angle B is equal to h over A. Okay, for here I'm going to multiply both sides by A and get that h is equal to A times the sine of B. Okay, so I have that. Now the next thing I want to do is I'm going to set, now that I've solved for h in both, the second thing that I'm going to do is I'm going to set the equations equal to each other. And what I'm doing is I'm going to set the equations equal to each other, equal to each other. And what I'm doing is I'm doing substitution from here, okay? And what I'm doing is, I have a system of equations, okay? So if I solve each of them for h, what I can do is I can plug in b times sine of A into h of my other equation, okay? So what we end up getting is we get this statement that b times sine of angle A is equal to A times sine of angle B. Now what I can do is I can now divide both sides by A. I'll do this one first. If I divide both sides by A, all of a sudden I have B times sine of A over little a is equal to sine of angle B. Okay. The next thing I'd want to do is I'd want to then divide both sides by B. And so then these b's divide out. And you are then left with this statement that sine of angle A divided by the side length A is equal to sine of B divided by the side length of B, of little b. This is the start of law of sines, okay? Now you're probably wondering, well, what about angle C? Where does that come into play? Well, and I'm not going to go through all of this again, but what I can do is I can rotate this triangle. And I could rotate it in such a way where I have angle C on the bottom, angle B here, and angle A up top. And I could draw in my height again. And I could do the same thing that I did here on this triangle with angle C as one of my bases. All right, and we would draw the same conclusion that sine of B would be equal to sine of C. Sine of B over side length B would be equal to sine of C over side length C. So the law of sines is this, okay, that sine of angle A divided by the side length A is equal to sine of B divided by the side length B is also equal to sine of angle C divided by the side length C. And what we're going to do is we're going to use this for any triangle. And what it allows us to do is to find the missing lengths of our triangle. and angle measures of our triangle. Okay, so let's go to the next page. All right, so let's take a look at the second page. And let's just write down the law of sines real quick before we do anything else. I'm going to write down sine of angle A divided by side length A is equal to sine of angle B over side length B. And that's all equal to sine of angle C divided by side length C. So what we want to do is solve the triangle, okay, using law of sines given one side length and two angle measures, okay? And so here's what we can do. The first thing, what we want to do here, and I'm going to write this down over here, is we want to write out angle B. I'm sorry, let's do angle A. Angle B and angle C. And then we also want to find side lengths A, B, and C. Okay, and that's what we're trying to do here. Okay, so first things first, we know what angle A is. We know it's 58 degrees. Whoop. Angle C is going to be 49 degrees. Now what we can do is figure out what angle B is, because all angles in a triangle add up to 180. So I'm going to take 180, subtract off 58, subtract off 49, and that gives us that the angle B is 73 degrees. Okay. So now I'm going to label our triangle here and call this side length A, B, and then C. Okay. Those are always just opposite from what those sides are. So side length B has a length of 33 units, okay? So now what I want to do is the math that we have to do that's going to be tricky is to figure out what A is equal to and what C is equal to, okay? So what we want to do, let's just use part of our law of sines. And I'm going to use, so for, to find A, so this is, let's find side length A, okay? What I want to do is I'm going to do use sine of A over A is equal to sine of B over little b, okay? And I'm just going to plug these values in. So I'm going to do sine of 58 degrees, okay, over A is equal to sine of B, so sine of 73 degrees over 33. Okay, and what we have here is we have a proportion that we can solve. So let's just cross multiply and solve for A. So I've got A times sine of 73 is equal to 33 times sine of 58. Divide both sides by sine of 73. Those are going to divide out. And so you have that A is equal to 33 times sine of 58 divided by sine of 73. Okay, and that's what we want to plug into our calculator. Yeah, so once you plug all that in, you get an approximate value. And let's just round to 3 decimal places for now. This is going to be 29.264, which is 3 decimal places. Okay, and that's that side length. All right, so now let's do the same thing, but let's find, so now, yeah. So side length A, 29.264. So then that's the side length here. So let me color that different color, 29.264. The last thing we need to find is side length C. Now, in order to find side length C, so find side length C. I'm going to also use, I'm going to do this. I'm going to set up sine of angle C over little c is equal to sine of B. Now you could use A but we already exactly know what B is. So if you screw up on finding the length of A, finding the length of C will get screwed up, okay? You can use what you found, but I would prefer just to use what you've already been given, okay? So let's jump in here. So sine of 49 degrees over C is equal to sine of 73 over 33, okay? And we can do the exact same thing, cross multiply. So C times sine of 73 is equal to 33 times sine of 49. Divide by sine of 73. Kind of running out of room here. I apologize. So then we get that C is equal to 33 times sine of 49 degrees over sine of 73. All right, so do the same thing, plug that into your calculator, and let's see what we get. Yeah, so then we get a value that C is approximately 26.043, and that's how we use, let me put this in here, 26.043, and that's how we go about that, okay? And then we can label your side length over here, so 26.043, and that's how we use that, okay? So that's that one. Kind of got enough room. All right, let's take a look at the other one. Okay, now in this example, I'm going to label this with x, y, and z's. So I'm going to do, this is length x, y, and then z. So to write out our it's going to be the same thing. So sine of big X over little x is going to equal sine of big Y over little y, and that's going to equal sine of big Z over little z, okay? And that's what we want to find. So let's find angle X, angle Y, angle Z. Let's find X, side length Y, side length Z, okay? So just knowing what we've got, we can find angle Z. Let's do 180 minus 104 minus 45. And that gives us that angle Z is 31 degrees. Okay, so I'm going to write all these down. So angles are pretty easy to find. So 45 degrees, 104 degrees, and then 31 degrees. Okay, side length X is going to be 35. So we got to find side length Y and side length Z. So let's jump in and do that. So I'm going to do, okay, what do we got? So which one? Let's find side length Y first, okay? So we have to use side length X because those are the ones that you're given, okay? You know for a fact that X is 45 degrees and that the length is 35. So let's do that. Let's do, let's find Y. So find side length Y. So I'm going to do this. Sine of 104 divided by side length Y is equal to sine of X, which is 45 degrees, over, what is that, 35? Okay, and then let's solve. So let's cross multiply. So we're going to get Y times sine of 45 degrees is equal to 35 times sine of 104. Okay, divide by sine of 45, divide by sine of 45. So then we get that Y is equal to 35 times sine of 104 over sine of 45. Plug that into your calculator. Okay, and that's going to give us a value of Y is approximately 48.027. Okay, so there's that value. All right. So we found that. Let's write that in here, 48.027. Okay. 48.027. All right, now let's solve for z. Okay, so we're going to use x as well. So let's, so find side length z. Okay. So we've got, let's use sine of x, so sine of 45 over 35 is equal to sine of z, which z was 31 degrees. Okay. Over side length z. Cross multiply. So we get z times sine of 45 is equal to 35 times sine of 31. Divide both sides by sine of 45. So we get that z is equal to 35 times sine of 31 over sine of 45. All right, plug that in your calculator. All right, so you get that z is approximately 25.493 degrees. Now, or not degrees, that's just side length. So what you want to think about here is, does this make sense? Now remember that that your side lengths and angle measures confirm kind of whether you've done this correctly. Remember, the largest angle measure is across from your largest side. Your shortest angle measure is across from your shortest side. Your middle length angle measure is across from your middle side. Okay, so you want to make sure that those correspond with each other, and that's how you can tell that you've done it correctly. Okay, let's do this next one. Okay, solve this triangle. Okay, so we've got two angle measures and a side length. So let's go through and let's write this down. We've got angle A, angle B, angle C, side length A, side length B, side length C. Okay, so we want to find each of these, and we're going to do the same thing. First thing we want to do is figure out what side length, or what angle A is. So I'm going to do 180 minus 40 minus 102, which gives me an angle measure of 38. Okay, 38 degrees. So let's go in and let's just write those down. So I got 38 degrees. Angle B is 40 degrees. Angle C is 102 degrees. Okay. So now we know that side length A is 20. Okay, but we need to figure out what side lengths B and C are. So let's go ahead and go ahead and find those. All right, so let's find side length. No, let's just do B. Okay, so what I want to do is set this up as sine of A, which is 38 degrees, divided by side length, angle A divided by side length A, so that's 20, is equal to sine of 40, which is angle B, divided by side length B. Okay, go ahead and cross multiply. So we get B times sine of 38 is equal to 20 times sine of 40. Divide by sine of 38. Those are going to divide out. B is going to equal 20 times sine of 40 over sine of 38. So go ahead and plug that into your calculator. What do we get? Okay, so we get that B has a value of 20.881, all right, or an approximate value. All right, so that's our value for B. So let's go in here. Now notice that that's really, really close to side length that we got for A. Notice how A is 2 degrees less than angle B. So side length B should be just a little bit larger than 20, and it is. So 20.AA, 881. Okay. 20.881. Let's go ahead and figure out what side length C is. All right. So find side length C. All right. So what I want to do is let's do sine of 38 over 20, which is A, is equal to sine of 102 divided by C. So let's cross multiply. So I've got C times 20, or no, I'm sorry, C times sine of 38 is equal to 20 times sine of 102. Divide by sine of 38, divide by sine of 38. So we get that C is equal to 20 times sine of 102 divided by sine of 38. And we should get an approximate value of, all right, so then we get an approximate value of 31.776, okay? And so just making sure that all these sides go in their specific order. So the longest side corresponds to the largest angle, smallest side corresponds with the smallest angle. Okay, so that's how we use law of sines. So it is a lot of work, but it's all pretty similar to what we've been doing. It's just finding what you need to know, what you don't know, all that good stuff. Okay, let's take a look at this last page real quick. It says triangle ABC has given the measures given. Solve the triangles if any exist. So let's do this. Let's just draw a quick picture of a generic triangle. We'll call this angle A here. So then this is 110 over here. That's side length A. Angle B we'll put over here, and we'll call this side length B. And then we have angle C, and this is 125. Okay. Angle A is 49 degrees. Okay, so we're given two sides and an angle. We want to figure out the rest of them. Okay. So let's do this. Let's figure out what angle C is, because once I figure out what angle C is, then we can figure out angle B right off the bat and then set up a proportion using law of sines to find angle side length B. So let's first, and I'm going to write this out as angle A, angle B, angle C. All right, so angle A we know to be 49 degrees. Okay, side length A is 110. Side length B and side length C we don't, or no. Side length C is 125. We don't know side length B. Okay, so let's find side length C. And the reason why I'm doing that is because I have angle A, side length C, but I don't have angle C. Okay, so let's find angle C. All right, so to do that, and I'm going to zoom way in here. You may want to write small. I'm going to do sine of A, which is 49 degrees, divided by 110 is equal to sine of angle C divided by 125. Okay, and we want to solve this for C. So let's cross multiply. And so we get 125 times sine of 49 is equal to 110 times sine of C. Now we're trying to solve for C. So let's divide both sides by 110. And so then we get 125 times sine of 49 divided by 110 is equal to sine of angle C. Now, in order for us to solve this equation for C, okay, remember we want to do the inverse. So this is where it gets tricky. So I want to do sine inverse of 125 times sine of 49 over 110. And that's what I want to put into my calculator. And that's going to give us the value for C. So here we get that C is equal to 59.051 degrees. And they probably want you to round to the nearest degree, but I'm just going to keep it at 3 degrees here. So 59.051 degrees, okay? And that's what angle C is. Now, we can figure out now angle B. All right, once we've found angle C in this case, we can do 180 minus 49 minus 59.051. So we got 79.949. So 79.949 degrees, okay? And then, so let's find side length B. So now we're back to what we were doing in the last page. So find side length B, all right? So let's do this. Let's do sine 71.949. 71. Did I write down 79? Dang it. I did. 71. That's what my calculator says. All right, so 71.949. Okay. And then let's divide that by B. And that's what we're looking for. And that's going to equal, and we'll still use A. We'll still use what we were originally given. So sine of 49 over 110. Okay, so now let's cross multiply, solve for B. So B times sine of 49 is equal to 110 times sine of 71.949. Okay, divide both sides by sine of 49 degrees. Sine of 49 degrees. Okay. So we get that side length B is equal to 110 times sine of 71.949 divided by sine of 49 degrees. So then this gives us a side length that is approximately 138.578. All right, and that's that side length for B, which makes sense, okay? So 138.578, all right, which makes sense because it matches up with our largest one. There is this thing called the ambiguous case of the law of sines. And I'm not going to really hit this very hard. Basically what it means is that when you have an original triangle here, you still can use the law of sines to find any angle measure within that and use that the same way. And it works for any triangle, whether it's obtuse, an acute, scalene, whatever. So law of sines is pretty powerful tool. So that's all I got, and we'll see you later. Thanks a lot. Bye!